Hi everybody, this is Mrs. Foy, and I'm going to do a quick demonstration about the sand and salt lab. So the whole purpose of this lab is to create a heterogeneous mixture and then separate it, using a couple of different separation techniques that we use in chemistry. So what is the heterogeneous mixture, you might ask? It's going to be sand, it's going to be salt, and it's going to be water. All right? So you have a copy of your lab. You should be following along with the procedure, even if you're not able to do it in class. Make sure you read the background information. It's a good review about heterogeneous versus homogeneous mixtures. So the first thing you're going to do is prepare your mixture. So it says I need to add at least but not exactly 2 grams of salt and at least not exactly 5 grams of sand. And I need to determine the mass of a clean, dry 250 milliliter beaker. So I have my beaker here, and I have my electronic balance that gives me the correct number of sig figs on my display. All right, so it's not plugged in, but I'm going to simulate this for you. And I put it on here, and I just write down the exact amount. All right, so you're going to record that in your data table. And then I need to get close but not exactly 2 grams of salt. So obviously I'm not going to pour salt on here. So I'm going to use a weigh boat. I wait for it to go 0, then I hit re-0, and then I'm going to take my salt and I'm going to sprinkle my salt in here until it is at least but not exactly 2 grams. So that looks good. I take that off, and then I'm going to put that salt carefully into my beaker that I already weighed. Then I'm going to do the same thing with the sand. I'm going to take a weigh boat, put it on my electronic balance, hit re-0 or tare, and then I'm going to take some sand. And it says at least but not exactly 5 grams of sand. So I'm going to add at least but not exactly 5 grams of sand. Looks good. And then I'm going to add that into my beaker, all right? And I'm not done with my mixture yet. I'm supposed to add 25 milliliters of distilled water. So my lab partner has some distilled water. I'm looking at the meniscus. It looks like exactly 25 milliliters. And so I'm going to add that now into my beaker. So now I have made a heterogeneous mixture of sand, salt, and water. I'm going to use my stirring rod, and I'm going to stir it thoroughly to dissolve the salt. Okay? I'm going to stir that. So then it says, my directions say to get the mass of a watch glass and a piece of filter paper. All right? So here is a piece of filter paper. I'm going to show you the one that's not folded yet so you can see. So I'm going to put my piece of my filter paper, and I need to make sure that I write my lab group's name on there. Otherwise, I'm going to get messed up. So I'm going to put the filter paper and the watch glass on my electronic balance, and I'm going to record that mass in my data table. All right, so now what I'm going to do is I'm going to start to separate my mixture. So what I'm going to do is I'm going to take that filter paper that I have already masked, that I've already masked, and then I'm going to fold it like a taco and then fold it again. And it makes, if you open it up like this, it makes kind of a little funnel thing. I should not see daylight through it, right? So if you fold it like this, you can see there's a hole through there, and that's not good. So you want to open it up just kind of like a little envelope, so nothing gets out. And then I'm going to put it in my funnel, and my funnel is in a Erlenmeyer flask. And there's a fun little technique that you can do to get the filter paper to stick on the sides. So you're just going to wet it with a little bit of water, and that makes it sticky on the sides. All right, so now nothing is going to leak. So now I've stirred and stirred and stirred my mixture, and now I'm going to use my first separation technique, which is filtration. So I'm going to pour my mixture through my filter paper and my funnel. This is called filtering. It's a separation technique, and I still have a bunch of stuff left in there. So my technique is I'm going to use my water in my squeeze bottle to squeeze out all of the mixture, all of the sand and the salt into my my filter. And I forgot to show you this really cool technique that you can use if you're going to pour something. This is called decanting. So if I add some more liquid here, you can actually use your stirring rod to help you to decant, right? So you're going to pour that off very carefully like that. So now you can see that my mixture is starting to separate, and knowing what you know about physical properties, you should know what is actually in here. And what is going to be separated out is still on my filter paper. So what I'm going to do is, after that is finished filtering, then I am going to take the filter paper, right? I'm going to take the filter paper after everything has already, after the water has funneled through it, and I'm going to put it on my watch glass, okay? So this filter paper has trapped the sand. Where is the salt? So you should know that, okay? So now I have a wet piece of filter paper with sand in it on my watch glass. Then you're going to give this to your teacher, and your teacher is going to put this in a piece of lab equipment called a drying oven, and it's going to do just that. It's going to dry this. It's going to get the water off, and it's just going to be left with the sand. And you should have written down the mass of the filter paper and the watch glass. Hopefully you did that. Otherwise, you're going to have bad results. So this, you're going to come back tomorrow, and you will have this dried for you, and then you will be able to mass your watch glass and your filter paper and your sand. The water should have been heated off, and then by a process of subtraction, you should be able to figure out the mass of the sand, right? And you knew how much sand you started with, so this is going to be an indication of how well you separate. All right? So now, what about this? Well, in here, in my Erlenmeyer flask, I actually have a mixture still, right? This is a homogeneous mixture of salt and water. And I need to separate that again so that I just get the salt back. So what we're going to do is we're going to use another separation technique. I'm going to use my hot plate, and I'm going to turn up the heat on my hot plate, and I'm going to boil off the water, all right? And you need to turn it up high enough to boil the water, but you don't need to have it so hot that as the water bubbles come up and boil that you hear a popping sound, and that means some of your salt is escaping. And if you see little pieces of salt that are around your table, you know that you have boiled it too much, right? And so, oh gosh, I forgot to transfer this because the directions say you're going to read your directions. I was just recording and not paying attention. But your directions actually want you to pour it back into your beaker. And this is actually good that I made that I did it this way, because you didn't weigh the Erlenmeyer flask, did you? So that would have been bad. So okay, but I weighed this beaker, clean and dry beaker, at the very beginning, right? So I can subtract the mass of the beaker when I'm done. So anyway, okay, you're going to put this on the put the beaker, because I weighed the beaker to begin with, on the hot plate. You're going to boil off the water, not too much because the salt will pop out. And when you are done, you should have a beaker where the water is gone, but the salt is left. You should have crystals of white salt. And then you would weigh that again, and you could subtract the mass of the beaker that you began this experiment with. And then you've got some calculations to do to be able to calculate the percent sand and the percent salt and see how much of the original mass of the sand and salt you got back. So I hope that's helpful, and I'll see you in class.